Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2018 Grade 12 Physical Sciences Paper 2. This question deals with 3 typical chemical reactions involving organic compounds. In the first reaction, butane reacts with bromine to produce 2-bromobutane and another product, P. In the second reaction, pentane reacts with excess oxygen in the presence of heat to form some unknown products. And then in the third reaction, hexane decomposes to an alkene and another product, Q. So the first question asks us to define the term homologous series. A homologous series is a group of organic compounds that have the same functional group, where each consecutive member differs by an additional CH2. The next question asks us to name the type of reaction represented by 1. So here an alkane reacts with a halogen to form a haloalkane, and in this reaction a hydrogen atom is replaced by a bromine atom, and this is called a substitution reaction. But the specific type of substitution reaction is called halogenation, since it is a bromine that replaces the hydrogen, which is a halogen. Okay, the next question asks us to write down the formula of the inorganic compound P. Since a hydrogen is removed from the butane and replaced with only one of the bromine atoms that reacts, the product P formed is hydrogen bromide, or HBr. The next question asks us to give the structural formula of a positional isomer of 2-bromobutane. So a positional isomer has the same molecular formula and still belongs to the same homologous series, but it only differs in the position of the functional group. So in this case, the functional group can be put on any of the carbon atoms, but only one will result in an isomer. So let's draw this structural formula. So it is bromobutane, which means that it has 4 carbon atoms. And initially it is 2-bromobutane, so the bromine is connected to the second carbon in the chain. Now, if we want an isomer of this, then we can't move it to the third carbon in the chain, because if we move it here, then we will just renumber the carbons 1, 2, 3, 4, and we will once again have 2-bromobutane. So the only isomer then is formed when the bromine atom is moved to the carbon at the end of the chain, and then the numbering is done from the side that gives the functional group the lowest assignment, the lowest number, okay? So each of these is then connected to a hydrogen in the normal way, and this is 1-bromobutane, or simply bromobutane, and it is the only positional isomer of 2-bromobutane. Okay, so then the next question asks us to use molecular formulae to write down the balanced equation for reaction 2. Reaction 2 is a combustion reaction, since an alkane reacts with excess oxygen in the presence of heat. So combustion reactions produce carbon dioxide and water. So let's write that balanced equation. Okay, so pentane has a molecular formula of C5H12, which we can get from the general formula of the alkanes, which is CnH2n plus 2. So pentane has 5 carbon atoms, and that's why it's C5 and H12. And this reacts with oxygen gas, so O2, and it produces carbon dioxide, CO2, and water, H2O. Okay, to balance this equation, we can start off with the carbons and hydrogens, since there's only one molecule containing carbon on either side and one molecule containing hydrogen on either side. So we need to add a 5 to the CO2, and that balances out with the 5 carbons on the left-hand side. And then we need to add a 6 in front of the H2O, and that balances with the 12 hydrogens on the left-hand side. So now all we need to do is balance the oxygen, and from the addition of the 5 and the 6, we now have 16 oxygens on the right-hand side. So what we need to do here is place an 8 in front of the O2, and that gives us 16 oxygens on the left-hand side as well. So this is the full balanced equation for the combustion of pentane. Okay, so we're then told that reaction 3 is an example of a cracking reaction. So we're first asked to define a cracking reaction and then give the structural formula of organic compound Q. So a cracking reaction is one in which a longer chain molecule is broken up into smaller molecules. And if we look at the third reaction, hexane is broken up into C2H4 and an organic molecule Q. So hexane has 6 carbon atoms, and we can once again find that from the general formula for the alkanes. So hexane has a molecular formula of C6H14, and compound Q is made up of the carbon and hydrogen atoms left after C2H4 is subtracted from that. So that gives us a molecular formula of C4H10 for compound Q. And we can now draw the structural formula. So from this molecular formula, we know that it is an alkane. So we can draw our 4 carbon atoms with single bonds, and then each of these is connected to the hydrogens in the usual way. And we can actually name this compound as well, and it will be butane, since it is an alkane with 4 carbon atoms. Okay. So before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.